I'm Ian Hawes. I'm a senior in environmental and natural resources engineering.
My name is Scott Krieger. I'm also an environmental and natural resource engineer. Our project is working on the trail conservation of Celery Bog. The big issue with Celery Bog is that the mulch there is getting run off during high intensity, short duration storms. And so what it's looking like is this figure here. A lot of the rain is creating the mulch to fly off. It's running and creating its own culverts. As in this picture, it runs on this outside on either side of the trails, and this was actually our target area, was in this whole location. So our goal was to figure out and design a proposal for the board so that Dan Dutton, who is our sponsor and also works at the facility, can provide different solutions so that the board can pick and choose which ones that they want to use according to their budget. We went out to the park several times. During that time, we took elevation data by using real-time kinematic system. We implemented the elevation data into ArcMap, and we got flow from there. And we also were able to notice just the different attributes that were going on, such as there's a culvert in this area that's already there. So we're able to look at that. We're also able to look at a drain that's also in the area, and it's sort of pick and choose and redesign. So Ian's going to talk a little bit about what we were able to do in calculations.
Right, so as you said, while we were out surveying, we kind of had a chance to see what current practices were already in place. And like you mentioned, there's already a culvert right here, but it doesn't really catch the runoff that's coming out of this wetland. And so we kind of thought of putting a berm over the trail to catch what's running down the trail, and then direct it to a little ditch that's right here. And we found there's currently a small French drain there that goes under the trail, but it's pretty small, and as far as we can tell, isn't very effective at all. So we thought it would be a good idea to put in a new culvert there to handle all of this runoff that's now coming down that trail. And up here, we figured out that a lot of the runoff that's coming down to this area is coming off this parking lot. It's just a lot of pavement, there's no infiltration, and all the water's immediately just going out into the trails. And so there's currently a small drain here with about a 4-inch tile that only runs out to this bridge. But really, that 4-inch tile is not big enough to handle all the flows, and even if it does get in the tile, it's just dumping it out onto the ground surface anyway. So our idea was to design a small mound right here to funnel some of this flow over to a new, bigger drain, and then run a bigger tile underground all the way out to the woods. And we really think that'll dry up this trail, and then with this berm drying up this trail, installing a surface drain right here will take care of the middle trail, and really we think clear up the main area that we've been having trouble with. And so this chart kind of runs you through the calculations that we did and some of the sources that we had. The rational method is pretty standard for small watersheds, and since it's not like a high traffic area, it's not a bridge under a road or anything like that, the rational method is usually suitable. Tile drainage and Manning's equation charts are pretty well established and everyone uses them. And then pipe flow and weir flow for our different culverts can be found in pretty much any hydraulics textbook. These are our final recommendations. We've kind of ran through them all already. These are just the specs that we came up with. And then the cost analysis. Dan currently estimates they spend about $100 remulching the trails every year. So here it looks like it might take 20 years to pay it off, and since it's only a 10-year storm, that doesn't really make sense. But really this is just a range of options. We're not really expecting them to do all of them, but implementing any one of these will help the situation to a certain extent. And then as funds become available over the future, just kind of pick and choose which ones they will do. And so these are our recommendations. Additionally, we kind of had different ideas that we tossed aside to a certain extent. So as I said, this 4-inch tile just goes to the bridge. Since they're putting in a new trail here, it'd be good to extend that tile all the way to the woods. It's not going to catch all the runoff, but it'll be better than just dumping it out onto that new trail. Along this driveway, there's currently prairie vegetation on either side, so it wouldn't be out of place to have a more prairie-like environment right here. Those extended root systems will increase infiltration. The thicker grasses will decrease runoff velocities, and it'll bring in more birds and wildflowers for the viewing area that's in the building currently. And then permeable pavement on the trails was discussed. it's very good as far as the utility of the trails, being able to drive trucks and vehicles, but it doesn't really preserve the natural aesthetics of the area to the extent that Dan would like to. So we kind of pushed that one aside, but we did come up with the idea.